All right, once again, we're integrating three separate terms. So I'm going to choose to rewrite by splitting it up into three separate integrals. So we're going to integrate 1 with respect to x plus e to the x with respect to x plus 2x. I'll go ahead and bring the constant out there. Kind of skipping a step there. We'll go ahead and bring the constant out, and then we're integrating x with respect to x. Okay, so now we're actually going to perform the integration. Okay. When we integrate a constant, then we just multiply that constant by x, so 1 times x would just be x. When we integrate e to the x, we just get e to the x. And then here we're going to bring the constant down. We're going to add 1 to the power and divide by the new power. So that would be x squared divided by 2. And then we're going to add our constant of integration. I'm going to simplify a little bit. On that last term, we have 2 and a 2. Think about that as 2 over 1. The 2's cancel, so we're left with just x squared, and then our constant of integration. For number 13, once again, we're evaluating or finding the indefinite integral. And we have, once again, three terms. So I'm going to choose to rewrite this by separating each one of these terms into their own integration problem. So I'm going to integrate the first term. It has a constant of 5, so I'm going to go ahead and bring that constant out. I'm going to integrate x to the negative 2 power with respect to x, minus, we're going to integrate x to the negative 3/2 power, also with respect to x. And then for the last term there, I'm going to pull out the 4, pull out that constant, and then I'm going to integrate x to the negative 1/2 power with respect to x. So I'm going to bring down the constant, add 1 to the power, and divide by the new power. So for the second integration, so now we are actually integrating. For the second one, I'm going to bring down the negative. It's kind of like a negative 1 out front, so I'm going to bring down that constant of negative 1. And then I'm going to add 1 to the power, which means I'm basically adding 2 over 2. So that gives me x to the negative 1/2 power, and then of course we're going to divide by that new exponent of negative 1/2. And then lastly, I'm going to say plus 4 times, and then we're going to integrate x to the negative 1/2 power. We're going to add 1, which is really adding 2 over 2. So we get x to the positive 1/2 power, and then I'm going to divide by that new exponent of 1/2. And then we're going to bring also our constant of integration. We're going to simplify a little bit here. So I'm going to write this as 5 divided by negative 1. That would be negative 5 times x to the negative 1 power. We're going to bring the negative 1/2, we're going to bring it to the top. We're going to multiply by the reciprocal. And of course, a negative times a negative would be a positive. So we have a positive, and when we flip that fraction, we get 2 over 1. So we're going to write that as positive 2 times x to the negative 1/2 power, plus, and then we're also going to flip the 1/2. Of course, that becomes 2 over 1. 2 times 4 is 8, times x to the 1/2 power, plus the constant of integration. Now, if I wish to, I could make the exponents positive. So I could write this as negative 5 divided by x to the positive 1 power, plus 2 divided by x to the positive 1/2 power, plus 8 times x to the positive 1/2 power, plus c. I would say either one of these last two would be perfectly acceptable solutions.